the reactions with alcohol. Now, if you react these compounds with alcohol, they are going to form esters. All right, so we have C2H5. Now, when we react this, it's going to give us ester. Now, how? This chlorine will react with the hydrogen from here to form what? Hydrogen chloride. And then every other thing there will combine together. So you are going to have CH3, C double bond O, here will be O, C2H5. Alright, plus what? HCl. So, and this ester is called ethyl ethanoate. This is ethanol. Is that okay? So that is that. Now let's see the other one, reactions with ammonia. What did you say about ammonia? All carboxylic acid and their derivative, when they react with ammonia, they are going to form amines. They are going to form what? Amines. All carboxylic acid and their derivative, when they react with ammonia, they are going to form amines. So this is going to form amines. You have CH3, C double bond O. Here will be Cl. Ammonia can also be written as this. Do you know that? Because this is NH3. Now, at the end of the day, when this one combined with this, it's going to form HCl. Right? Now, finally, this is going to give us CH3, C double bond O. Here will be what? NH2 plus HCl. Is that okay? Now the next one is the reactions with primary and secondary amine. They are also going to form substituted amines. They are going to form what? Substituted amines. So in this case, if you have something like this plus this is the primary amine, these are primary amines are. Now still the same procedure, these two things will combine. All right, and then at the end of the day, you are going to form arrow C double bond O, NH arrow. This is N-alkylamide. N-alkylamide, to tell you that one of the nitrogen here in the amine is substituted with what? With an alkyl group, which is this arrow group you can see here, N-alkylamide. Then with secondary amine has two arrow group. So you have something like this, arrow C double bond O, Cl plus H N, and then you have arrow 2. Now with secondary amine, they are still going to form N substituted product, this arrow plus HCl, because of course we say these two things here will combine together to form HCl. This is going to form NN dialkylamide, N, N dialkylamide. So you see that with all ammonia and primary amines, all of them, they are gotten from where? They are gotten from ammonia. So you see, from ammonia and all its derivative, they are also going to form amines. But for ammonia, they are going to form the amines. While for the primary and secondary amine, they are going to form substituted depending on the degree. First degree will form N-alkylamide. Second degree will form N-dialkylamide. Then when you now react it with the salt of carboxylic acid, it's going to form ester. It's going to form acid 100 rather. When you react it with the salt of the carboxylic acid, it is going to form acid 100. So what will be there is that it's going to form sodium chloride. So sodium and chlorine will react. Now one thing that you should know in this exam is your ability to know the structures of what they actually ask you to draw. Sometimes they may ask you something, but because you don't know the structure, you will just mess up. So this will be C double bond O CH3 plus sodium chloride. Alright, so that is that. Now, how about reduction? When they are reduced in the presence of palladium catalyst, they form aldehyde. Now, the above reaction is known as the Rosimond reduction. We've talked about Rosimond reduction, where you have palladium with barium sulfate poisoned with what? Sulfur. The reason why we are poisoning it is so that to prevent further reduction to what? To alcohol. So it will end at only the aldehydes. And we said it's one of the ways of actually making aldehyde and preventing further reduction to carboxylic acid, specifically for aldehyde. So if you want to form aldehyde from acetyl chloride, you use this reagent. So we have plus H2 palladium and barium sulfate. This will give us CH3 C double bond A H plus what? HCl. Alright, what reaction is this? I said the Rosimond reaction. Is that okay? So that is that for the carboxylic acid. Now, we also said when they are reduced with lithium aluminum hydride, they form primary alcohol, like the acid anhydride. Like the acetic acid, they form primary alcohol. So all carboxylic acid and their derivative, when you pass them through this reducing agent, you are going to give us primary alcohol. Alright, that is that. Now, the next functional group we are going to look at before the next functional group, we have Frederick-Kraft acylation, Frederick-Kraft reaction. Now, if you were learning this in your year 2 first semester, you learned Frederick-Kraft reaction. We say Frederick-Kraft reaction, they are classified into two. We have the acylation reaction, and then we have the acylation reaction. Frederick-Kraft acylation and Frederick-Kraft acylation. Now, for acetyl chloride, is called the acylation reaction. So what happened is benzene and its derivative, which is aromatic compound, can undergo this reaction with acetyl chloride, and it's one of the important reactions in the synthesis of ibuprofen. Ibuprofen is solid, a good analgesic. Good analgesic. Some of you take it during your period cramp. So you have acetyl chloride. Now this reaction takes place in the presence of Lewis acid catalyst called aluminium trichloride. Now what will happen is remove this chlorine and then attach this to the benzene ring. It's just a layman understanding of this. So if you want to learn the mechanism of action, you have to learn it very well, how the ion is formed and then it attacks and then hydrogen is removed and then the other bonds kick in and so on and so forth. But this is going to form a ketone. Now what ketone is this? It forms acetophenone. Alright, you should take note of it. It's very, very important. Which of them makes it ketone? This is the carbonyl functional group. Carbonyl functional group. Do you understand? So that is that. Now, this reaction, like I told you, takes place in the presence of Lewis acid catalyst like aluminum trichloride. Alright, Frederick-Kraft reaction. Like I told you, Frederick-Kraft reaction is divided into acylation and acylation. Acylation is the addition of the acyl group, because this group here is called an acyl group. What kind of acyl is this? It's called acetyl group. We have other longer acyl group, alright, like your propionyl group and so on and so forth. Alright, now acid anhydride. What is the general formula for the acid anhydride? They have the general formula of ROCOC double bond O R. Alright, that is the general formula of the acid anhydride. Now, what are the methods of preparation? We can prepare them from carboxylic acid. Very simple, right? We've learned something like this just now, not quite long. We can prepare them from the carboxylic acid via condensation reaction with the elimination of what? Water. So you remove water from this reaction, and this is going to give us O. If you remove water from here, you see how easy all these things there. I just want it that you are removing in most of the cases. If you understand it on that basis, then it becomes very easy for you. Remove water. Are you getting it? So this is going to give us the acid anhydride. Another method again is from the sodium salt of carboxylic acid with acetyl chloride. We learned something like this. The acetyl chloride will, or alkyl chloride will learn just now. Now this one is going to remove sodium chloride. We learned something like the under reaction of the acyl halide, and this is going to give us ROC double bond O. Here will also be OC double bond O, then CH3. This is also another method of preparation of the acid anhydride. All right. Now, how about reaction? Now, if you hydrolyze the acid anhydride, if you hydrolyze them, when you talk about hydrolysis, it means you are passing water through them. Now recall that how did you form them? You remove water from 2-carboxylic acid to form this. If you add the water back, it's going to form the 2-carboxylic acid again. So in this case, if you add this water back, all you need to do is divide this thing at this middle here, and then you are going to get the 2-carboxylic acid that reacted, which is CH3C double bond O. Then here add OH plus, here write OH normal, there put C double bond O, and here's what CH3. So this is one of the reactions that they can undergo. You can actually break them to give us the carboxylic acid. All right. Now reaction with alcohol. Now when they react with alcohol, esters are formed based on our understanding. When they react with alcohol, esters are formed. How? It's very easy. Now just note that in every case you are going to form ester, and then you are going to form a carboxylic acid again. Is that okay? Now what will happen is that this OH will actually bind with one of this group here. So if this OH bind with this, it's going to form an acid. Then this group here wait. Are you sure? Okay, reaction with alcohol, not reaction with carboxylic acid. I have a conf here. So here it's supposed to be CH, because it's not making sense. CH2, CH3. Good. So when this one combine with this, it's going to form a carboxylic acid. Then this two group here like this will combine with each other. So this is going to give us CH3, C double bond O, O. Then here will be what? CH2, CH3. Then these two things combine together to give us something like this. Is that okay? That is one of the ways. This is ethanoic acid, and this is ethyl ethanoate. Is that understood? So that is one way. Then when you react it with ammonia, what did we say? That whenever you react carboxylic acids and its derivative with ammonia, amines are formed. Is that okay? Amines are formed. So this one is very easy too. You have something like this. Prototype of this group is acetic anhydride. That is what we will be using since. With ammonia. Now what do they do here? Very easy. This nitrogen here combine with this group to form acetic acid. Then these two group here combine with themselves to form amide. So what do you think this is going to form? CH3, C double bond O, NH2 plus amide plus acetic acid rather, CH3, C double bond O. There you have OH. All right. So this is ethanamide. Ethanamide. This is acetic acid. So that's basically all under this particular one. I think that'll be all for now. Coming more with more classes. All right. Thank you very much for your time. See you in the next one.